Next thing I want to try is a computer table built into a corner. And the important thing here is that I want to have the keyboard here and the monitors back here. I want to keep 20 inches across there at 45 degrees, always in the same relationship to the origin point. When I adjust the lengths of the right and left legs, I don't want the angled keyboard edge to change its position, angle, or length. And I think what I'll just do is draw this perimeter. It would be an extrusion. I'll go out here, let's say 5 feet. Come down 30 inches, that's going to be a constant. And then come in here somewhere. We'll worry about where that ends up later on. And maybe come down here 6 feet or something, over 30. And then up. So it took me a minute or two to figure out how do I draw that line in there at 45 degrees and 20 inches long and have it be in the right place. And the answer is draw it right first and move it into place. I'll just start here. And you see I'm coming up at 45 degrees and I'll just wait till I get to 1 foot 8, like that. 45, 1 foot 8, click. Then just move this down, MV from here to here, and it's in exactly the right place. It took me longer than that to figure out how to do it. I sometimes I've done this demonstration, this same object before, but not for a year or two, and it's I just forgot what I was doing. So it turns out that all I need, I've already got these two origin planes because I'm figuring this is going to get stuck into the corner of a room. We can move it around. I've already got those. So really, what I want to do is be able to control let's say the right leg and the length of the right leg and the length of the left leg. So we can go to, okay, I'm done creating this object for now. We'll deal with that later. Create reference plane. Drag that down. Create reference plane. Drag that down. Now let's just see what happens if I quickly, can I lock that into that right now? Apparently not. I guess I have to go and edit extrusion and lock it. Okay, and just see what happens if I drag that out. Okay, well, staying put, this guy, but I want to really be sure I lock it in place. So I am going to do this, create reference plane here up like that. And then pin it with this tool right here, modify pin. Okay, again, we'll just put these dimensions on it. Annotate, aligned. And we don't have any equals things going on here since it's not centered. One thing I do want to do is to fix these dimensions at 30 inches. So I'll go to annotate, aligned from here to here, and just lock those to make sure they stay in place. Because we can manipulate this object out in the project environment with shape handles, and I don't want those to accidentally become 24 inches wide or 3 feet wide. Oh, and then last but not least, I want to fix this at 20 inches. I'm going to edit extrusion. Now I want to dimension on that angle, annotate, aligned. Right now I'm dimensioning from 2 points here, from this point to this point. And I want to lock that in at 1 foot 8, 20 inches, just to make sure nothing stretches out of place. Let's see what this does back in the project. Okay, that's good. I need this to be shorter this way so it doesn't bump into the door. So I don't have my dimensional parameters assigned to this yet. I have the links done, but I don't have parameters out here to deal with. So go back to Edit Family. And this time, when I'm turning these into parameters, I am going to do them by instance, because we might have 3 different sizes of this to fit into an office, fitting around columns, perhaps. I might have one in one corner that's 5 by 6 feet and one in another corner that's 4 by 7 feet. So this, just to see the difference, I'm going to pick this, change it into a parameter called left leg. And I'm going to do this one by instance. And pick this one, assign a parameter, right leg, instance. Okay. Control S. Let's call this computer corner work top. Okay, this is our old one with a different name. If we assign instance parameters, we can size the worktop either with the shape handles or with the dimensions and properties. Get this till it looks good with shape handles, and then come in and say, oh, that left leg, let's just make that an even 6 feet. And you get the, rounding off the nearest inch or something, and then we pick this one and see, well, it doesn't want to be 411 and 155, 256, we'll just make that one 5 feet. Makes the cabinet makers happy. So if we had another one in another corner, I'm going to rotate this around 180, I guess, huh? Nope. And something I try to do with these is not mirror them, because then things like left leg and right leg get confused about which one is doing. I would rather rotate them and do that, and that way this one might have, maybe for some reason that one has to come clear to there, and I can do that with 2 different shaped, 2 different instances of the same family, of the same type, using instance parameters. Let's put the holes in that. We set the table legs in a given distance. Here I like to have like some 4-inch round holes to run cables down through. And if you remember, let's say that they're also going to be like 4 inches in from each side. So I'll draw reference line. Sorry, not reference line, reference plane. Reference lines have another use that we'll get to someday, not reference plane, sorry. Create reference plane. And I'm going to put these, I'm just going to make that the same 4 inches. And then if you remember, any extrusion, if we draw a shape, go to edit extrusion, any shape we draw inside it becomes a void. So I'm just going to put some 2-inch radius holes here. So there's that. And lastly, I like to make the size of the holes controllable. Let's give that a shot. And what we'll use here is we have 3 separate holes, but we'll use the same parameter to control the diameters of all 3 of them. So we'll go into Edit Extrusion, annotate diameter. Where are we going to put it? Diameter. Diameter. And then I'm going to take this and turn it into a length one called hole diameter, and this will be by type, okay, because that's not going to change from office to office. They'll all have the same 4-inch grommet for the wires. And having created that parameter for that hole, I can pick this and use the same parameter over again for these guys. See how that works. So now when we pick this, we can go to edit type, because that's going to affect all of them. And we have a hole diameter being 4 inches. We set that down to 3 inches. We'll set down to 2 so we can really tell the difference. Apply, and they shrink down on both of the worktops. So with enough forethought and enough experimenting afterthoughts, we can do a great deal here to make them behave the way we want them to behave. And again, I give this a height and a thickness just the way that we did for the table. Right now it's a foot thick and sitting down on the ground, but you can figure that out. The last one I want to deal with is the bookcase here. I'm saying it's 12 inches deep with parameters for width and height. So 12 inches as fixed, the depth, parameters for width and height, and then 4 shelves that are 3/4 of an inch that adjust to be equally spaced depending on how high the thing is. Take a deep breath. File, new family furniture. And based on your experience from having done your Revit families, how do you suggest we put this together? What's a good way just to build the case part of it? Extrusion from the floor up, from the front back? I think the point is that there are numerous ways to do this. One would be to create a whole volume like that and then do a void that goes almost to the back and subtract it out. Just subtract out the hole. Another would be to draw it in elevation, make it 11 inches deep, and then put a piece on the back of it. We can join them to make them look like one solid object. Let's do that one because it will give us an opportunity to join elements so we don't see where they touch. There's often many completely acceptable ways to model something, and you have to figure what's the most expeditious and what is the one that I'm going to be able to alter most if I need to change it. Where can I put my reference planes? But let's try this one from the front just for a change of pace. So go into a front view, and I'll create that big extrusion that's, let's say I'll start by making it 3 feet wide and 5 feet high. So I'm going to make an extrusion. So I'm going to do that, and I'll move it later on. Or maybe I'll just move it right now. And I'm going to move it from here to the middle just to get it lined up. And then I'm going to cut a big hole all the way through it. And I'm going to offset these around the top and sides 3/4 and here by like 4 inches. So I'll go to offset 3/4 inch. And then offset the bottom one 4 inches. And then to make this continuous, I need to trim trim this to be a rectangle, so I'll use the trim tool. Good enough for right now. I'll look at that in 3D. So there's the beginning. At this point, this doesn't have a back yet. So what I think I'll do is, instead of putting one all across the whole bookcase, behind the whole unit, I'll just build a back piece right inside here. I'll go back to my front view. And I'm basically going to use this interior rectangle to create the back, create extrusion, rectangle. And the only difference is, compared to the other one, that one started at 0 and came up a foot, which is to say this back plane coming a foot up towards us. This one is going to start at 0 and just come up, let's say 1 inch, or 1 inch thick back. I'll just draw this rectangle, see if that worked out. So you can see that sitting inside. So started at 0, came out towards us a foot. This one came out just an inch. When we get around into back views of this, we don't really want to see that as a separate piece of wood or whatever. So this great tool over here called join will take two objects that are of the same type and treat them as one object. As far as joints are concerned, they could still have separate materials. It basically just hides the lines where they hit. They're still two objects as far as Revit is concerned. So most of our important dimensions are going to be here on the front. I think for the width and the height, but we do need to do the depth in a plan view. I'll go back to my floor plan view. So it's all coming from here. This is where those guys were built, so they're going to stay there. We need to tell them how far to come out forward. So I'll go to create reference plane. Drag this down here and lock it. And then create a dimension and give it a depth parameter to set the depth. We'll do all the other dimensions in the elevation view. Annotate, align. We don't want that fixed. We just want to give it a name by type. Going to our front elevation. And here's something to remember about which views to do this work in. You don't want to use these views. These are actual 3D views where you can't dimension things appropriately. We actually, even if it looks like it's a front view, it's really a 3D view that happens to be from the front. We want to get into true elevation views to do all the dimensioning. So I'll draw as before. I'll draw one for height. Create reference plane. Height. And I'll do one for each of the sides. Create reference plane. You should pretty much know the drill by now. So let's create these dimensions and give them parameters. We want this to stay centered on its placement point, so I'll make those equal again. And assign names to the width and the height. Again, by type, we'll be doing, almost all this furniture, except for truly custom stuff, will always be by type. So you can update multiple ones of them at the same time. So even before I start playing with the dimensions, you know, I want to basically I want to see here is how do these 3/4 inch and 4-inch offsets work when I it's called flexing this to move the muscles to see how the bones and the flesh behave. Well, this happens because I haven't locked this to it yet. Control Z. I'll drag that up and drag it back down and lock it. Drag the outside over, drag it back to the reference plane and lock it. And the same on the other side and lock it. So now when I drag this up, the 3/4 inch top went along for the ride, but the extrusion didn't go, the back piece. So I'll need to drag that up to there. Let me that's the back. Let's just drag this up to here and lock it to the underside of that and see if all these behave themselves. Looks like they do. If you want to be able to control the thickness of the sides and the top, we can put dimensions on them, but I'm not gonna do that right now. So the next question is, I want to put 4 shelves in there and have them spaced equally, regardless of the height of the thing. So I think I'll do those in this elevation view. We could draw them in plan. We could draw them in elevation. Doesn't matter. But we're going to end up dimensioning them here, so we might as well just do it. Create extrusion. I'm just going to create one of them right here. And so the edges show up. I think I'll move these in just a little tiny bit, just so we can see where they hit. And this one, if you remember, working from the back of the whole piece of furniture is 0, and the back of it's 1 inch thick. So these will like start at 1 inch and come out 10 inches. So they start at 1 inch. We can see that in plan. Actually, let's say they come out 9.5 inches, so they don't go all the way to the front of the unit. And before I go to copy that, I'm going to just go into the 3D view to see if that's what I want. Well, it's not, because right now my depth is too deep. Let me take this back to 12 inches. So maybe I'll make that deeper. Bring it out to here. Okay, that works for me. So now these other three shelves get into the front elevation here. I'm going to copy them up just with control drag just to place them there. And I'm going to use the same equality dimensions to move them so they'll be spaced equally regardless of the overall height. I'll go from the top of this to the top of that, 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 and just say equal. See where we get. Annotate, aligned. Top of here, to 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 top of here, over, and then equal. It's almost too easy. So let's see what happens if I change the height of the whole thing. This is always the proof of the pudding. Let's make that 6 feet. Yes, and up they go. And there are more complex ways of doing that, where you can say, have them every foot apart, and if I go up to 8 feet, add extra shelves. And I rarely am involved with things at that level of sort of programming. So there's this. We have parameters for height, depth, and width, which is fine. I realize that I should probably have made the depth of the shelves adjust with the depth of the whole case another time. In my furniture folder, storage for shelf bookcase parametric, and then load it into the project. And that too, we can assign materials or different materials or whatever we want to do to those.